Here we're going to look a little bit more into timers and just of some of the subtle features that come with it that maybe aren't initially too obvious, but are very important that we need to understand in order to set up our code. And really we're going to look at the way latching can play a role in this. Okay, so if we just take our timer on, so this discussion is just around an on delay timer. Remember, an on delay timer will turn on an output after a delay in time. So that's different to an off delay timer, which we will look at in a different video. So at the moment, what we have is an input, our start button, and then we want to wait 5 seconds before we turn on this Q1 error LED. So it's just an indicator LED. So let's just see what happens. I press the start button. You can see it counting up there to 5 seconds, and then the Q1 turns on. So that seems fair, that I've pushed the start button, a delay in time has happened, and then the Q1 error LED has turned on. Now, if I take my finger off the start button, look, the Q1 error LED turns off. Okay? So then that, poses a question here. Well, what if I only briefly push the start button? You see, it starts to count, and now I take my finger off. It loses its energy, and it won't. It needs a latch signal pretty much to count up to the 5 seconds and then turn it on. It needs a constant signal here. So if I'm using a push button, that becomes really difficult because now I have to keep my finger on it for 5 seconds to keep the light on, and then I've got to still keep my finger on the button to keep that LED illuminated. Now it might not be too bad if we use a key switch because that will stay mechanically held in. But the problem is, what do we do when we have push buttons, which are, really common? So it just poses the problem, or just the characteristic, that this timer on delay needs to have a latched input most of the time if you're looking to just press a button and then for it naturally to count up and then to stay on. So what I'm going to do here is I'm just going to insert a new network just above it, although the position isn't important. And what I'm going to do is I'm going to set up my usual latched circuit. Okay. And we're just to visualize this, what we're going to do is we're going to use the two LEDs that's available. Okay. So there's a Q1 error LED and there's a Q2, just so we can again visualize what's happening here. So we're latching this on, and then we're going to use this latch signal as an input to our second line of code, and we'll just watch how this works. So we have our previous latched signal. Okay, that's going to latch on the Q1 error LED, and then what I want to happen is after 5 seconds I want Q2 to turn on. And if we look at those two lines of code and I try and say to myself, well, what is latched on? We know Q2 is going to be latched on straight away from pressing the start button. So I could use that as an input down here, because remember we can refer to outputs as inputs within our code. And now that will join the two lines together and we'll see what will happen here. So this is just one simple solution, just so we can visualize our outputs. You could use markers or memory bits to do this as well. But let's just have a look at it now. All going well, that's the code in correctly. So let me, did I download it in? I can't remember. Let's just do a quick download just to be sure. Finish. Looked like I did. Go back online, and let's look. Press the start button. I can take my finger off it because this is being latched in. Look, one light, and then the other light comes on after 5 seconds, and it stays on, and I don't have to keep my finger on the button. So we're using this line to feed itself in down here. And how do I turn off? Well, if I turn off both them lights, I do that through the reset button. They'll both turn off at the same time because the reset button will break the Q1 error, which will lose the supply to the timer, which means the timer loses its sort of power, its energy, which will turn off Q2. So hit that and the both of them will come off at the same time. So you'll notice I just have to briefly press the start button, Q1 error LED gets latched on, it'll power up the timer, and then the Q2 turns on after a 5-second delay, and then I can press reset. So some key characteristics with the timer on delay Remember, on delay timer turns on an output after delay in time, or turns on a memory bit or something after delay in time. But we need the signal to be latched coming in. If we're using something like a push button or something like that, that's not going to be mechanically held in. As I said, it could be different if you're using the start or the key switch there, because when we turn that, that's mechanically held in. So that could be useful. We could make use of that characteristic of the input, which would change our coding. But hopefully you can visualize that a little bit more. And this monitoring mode is very useful, and we can see that's that real value of the timer. If you watch this split here in gray, if we press start, see that there, it's showing us the real value of the timer. That's actually what gets stored in here in that ET, the elapsed time. That's constantly showing us this updated real-time version of the timer. So if you needed to store that information somewhere and then display it to the user in, say, a HMI screen or something like that, you would utilize this and declare something in there. But for the moment, we're not doing that. So that's the timer on delay and some of the characteristics that come with it that maybe just aren't too obvious on the outset.